In this video, we're going to come up with a formula for writing down the vertex of a parabola, the graph of a quadratic function. Consider this quadratic function, 2x squared minus 4x plus 8. I'm going to go through the sort of analysis we've done before in order to locate the vertex. Notice that if I factor out the greatest common factor of 2, and then split up this 4 into 1 plus 3, then these first three terms combined can be factored as x minus 1 squared. And that puts this equation in vertex form. From this, I can read the vertex as 1. And let's think about now where that 1 came from. How did we get it? Well, first we had a minus 4 there. We factored out the 2 out front. So we had the minus 4, which was b. And we factored out this 2, which was a, where I'm thinking of a, b, and c, just like I do when I use those to represent the coefficients in the quadratic formula. So that's where this 2 came from. And then if you think about how we ended up factoring this expression, this number 1 is half of this 2. So I really took the b divided by a and divided that by 2 again, and I can represent that just by writing a 2 in the denominator. And one more thing, I don't really want, if I think of this carefully, the b is negative 4, but b over 2a would be negative 1, and my vertex isn't negative 1, it's positive 1. So I actually need to throw in another minus sign here in order to compensate for the fact that I'm really subtracting the vertex. So this number, the quantity we see in the vertex form, where we can tell it is the x value of the vertex, came from taking this combination of the coefficients of the original quadratic function. So this summarizes the analysis we just went through again. We take this coefficient b, which is negative 4. We factor out this coefficient a. We divide by 2, so we're really dividing by 2a. And then we need to change the sign. So that's where this formula comes from, negative b over 2a. That's the formula we will use whenever we need to find the x-coordinate of the vertex for a quadratic function. Let's take a look at an example where we will do that. Here we have a quadratic function, 3x squared minus 12x plus 1. So first I identify the coefficients, just like I would if I wanted to use the quadratic formula. A is 3, b is negative 12, c is 1. I don't actually need c for this application. I really only need a and b. So to get the x-coordinate of the vertex, I plug a and b into this formula, giving me negative b, which is negative 12, over 2a, where a is 3. And then I just want to simplify. These two minus signs can cancel, and 2 times 3 in the denominator gives me 6. And then 12 over 6 simplifies to 2. And that's all it takes to tell that the x-coordinate of the vertex is 2. Just plugging the right coefficients into this formula. To get the y-coordinate of the vertex, I can use the fact that I know the x-coordinate and plug it in to the formula for the function f. That will give me the y value that goes with that x value. So I just get the y-coordinate of the vertex by plugging the x-coordinate into f. If I evaluate that, plug a 2 in everywhere I see an x, so that gives me 3 times 2 squared minus 12 times 2 plus 1. And simplify that, we get negative 11. So in summary, the vertex has an x-coordinate of 2 and a y-coordinate of negative 11. And I can verify that on a graph. Here's the vertex. It lines up with 2 on the x-axis, and it lines up with negative 11 here on the y-axis.